I'll begin this video on projectile motion by giving a few examples of projectile motion. Let us begin with very simple examples of projectile motion. Let us say we have a container, right, of some particular liquid, and then let us say there's some liquid over here, and let us say by some means we are able to make an opening over here. The path that the liquid will follow will be something like this. And this is an example of projectile motion. Right? The path that the liquid takes is known as trajectory, and the motion is known as projectile motion. Right? One more example. Let us say this is a ground, and there is a person standing over here, a player over here, and he throws a ball. And let's say he throws a ball in the horizontal direction. So the path that this ball takes is something like this. Right? It has taken a path like this. This is again an example of projectile motion. Right? We may also have a situation wherein you have a person standing over here, and this is say the ground, and he throws a ball up in the air, something like this, and this is the path that the ball may follow. This is again an example of projectile motion, and the path, as I said, is known as trajectory. So we have seen a couple of examples of projectile motion. There could be some other examples. For example, the bullet coming out of a gun is also an example of projectile motion. Having looked at these examples, let us try to understand the characteristics of the projectile motion. How is it different, and what are the characteristics? First, right, the motion is two-dimensional, right? Or it is also known as plane motion, because the object is moving in a plane, or the object is moving in two dimensions. If I take this example, right, the object in this case is moving in the horizontal direction, and then we can see that it is moving in this direction, the horizontal as well as the vertical direction. If I look at this particular path, right, I can see the object going up as well as going in the horizontal direction. So the object is moving in a plane, right, two-dimensional plane. Therefore, one of the characteristics of projectile motion is that the motion is two-dimensional or plane motion. Right? That is one. Second, let us look at the velocity of the object. Let us look at the velocity. Now, if you look at this particular motion of the object, it's going up. The velocity has two components. One, a horizontal component, VH, and a vertical component, we will denote it by VV. Because the object is going up as well as forward, therefore it has two components, VV and VH. So we have VH and we have VV. Now, if you look at it very closely, once the object leaves the hand of the thrower, right, there is only one force acting on it, and that is the force of gravity. Right? So the only force acting on this, but if the object is over here, it has two components, VV, VH. The only force acting on it is force of gravity, Fg, right? If I can call it force of gravity. If that is the case, there's no force in the horizontal direction. So Fh is equal to 0. Fv is equal to force of gravity, right? Fg. But there is no force acting in the horizontal direction. There's only one force acting in the downward direction. If Fh is 0, right? Now force is mass into acceleration is equal to 0, right? And therefore acceleration, if I can denote it by Ah is equal to 0, right? That means the acceleration in the horizontal direction is 0, right? And if acceleration is in the horizontal direction in the 0, I can say delta V, that is change in velocity in the horizontal direction, is equal to 0. So there is no change in velocity in the horizontal direction. Therefore, VH is equal to constant, right? This is change in velocity in the horizontal direction, that is 0. VH is equal to 0. As far as the vertical direction is concerned, there is a force acting, as we said, force of gravity, and therefore the velocity in the vertical direction is not constant, it is variable. Right? So this is how the velocity changes. This is another important or very important characteristics of projectile motion, which says that the velocity in the horizontal direction throughout the journey remains constant, whereas the velocity in the vertical direction keeps on changing. Right? So this is the second characteristics we have looked at from projectile motion. Third, let us look at acceleration. As we discussed, the only force acting on this object while it is undertaking projectile motion is force due to gravity, right? And therefore this is equal to m into a. Since it is force of gravity, this a is actually g, acceleration due to gravity, and therefore this acceleration is equal to g. Right? What we say is that when the object is performing projectile motion, its acceleration is g, right? Because there is no force other than the gravitational force acting on the object. So we have looked at three characteristics of projectile motion. Right? Let's move further. Let us look at. Let us try to understand this with the help of a vector diagram. Right? Let me take an example. Let us say an object is performing projectile motion, and let us say we are it is at the topmost position, and then it's going down like this. Right? So at the topmost position, its velocity. Let us say this is one position, and this is position number 2. So when it is at the topmost position, there is only horizontal component VH, or we will call this V1, right? V1. Whereas here the velocity is in the downward direction V2. Right? So if I want to find out the change in velocity, I will have to find out V2 minus V1. So if I use a scale and try to find out if this is V2, right? So I will draw a line V2, some arbitrary length V2, correct? And V1, right? V1. This is V1, right? This is V1, this is V2, right? Note that I have taken V1 smaller than V2. Quite naturally, as the object is going down, V2 will be larger, V1 will be less, V1 will be smaller. So this is V2 and V1. And what would be the change in velocity? If I want to find out V2 minus V1, so I'll join this, and this is V2 minus V1. Right? And as you can very clearly see, the change in velocity is in the downward direction. Right? Change in velocity is in the downward direction, and as we discussed over here, acceleration is in the downward direction, right? Because the change in velocity is always in the downward direction. And this is another important aspect of projectile motion, right? Okay, let's move further. I want to discuss another. So this is the fourth thing that we have discussed. I want to discuss one more thing related to projectile motion, and let us say we have this is a tower, for example, and let us say there is an object A, right, which is dropped vertically downward. This is object A, and let us say same object, right, or let us say these are two similar balls, right. One is dropped, if the ball A is dropped vertically downwards, and exactly similar ball B is thrown in the horizontal direction. Right. It is observed that both these objects reach the ground simultaneously at the same time. Why is it so? We can understand this by the discussion we had before in the earlier part of the video. If I use this equation, S is equal to ut plus half at square, I can understand this very clearly. If I look at displacement, for both the objects, displacement is same. Displacement is from this point to this point. So this is the displacement for both the objects, whether I am dropping it downwards or I am throwing in the horizontal direction, because displacement is the shortest distance between the starting point and the final point. So S is same for both the objects. Initial velocity U is also same for the both objects, because here when you drop it from the top, initial velocity is 0. When you throw it in the vertical direction, the horizontal direction, the vertical component of velocity is 0. For this, when you throw it in the horizontal direction, the vertical component of velocity is 0. That means U is 0 for this object in the downward direction. It certainly has initial velocity in the horizontal direction, but in vertical direction, U is 0. So for both objects, U is 0. So U is same. A is also same, acceleration. Both the objects are falling under the influence of acceleration due to gravity. There is no other force acting on them. So A is also same. So if I look at this equation, S is same for both the objects, U is same for the object, A is also same for both the objects. The only thing that remains is T. And therefore T is also same for both the objects, because every other physical quantity is same. And that is why we say that both the balls will reach the ground simultaneously. Okay, so this is another example of projectile motion that I wanted to discuss. Sixth, we will quickly discuss a couple of assumptions that we make for projectile motion. One is that we neglect air resistance, right? Because when the object is falling down, there is an upward force, air force acting in that upward direction, but we ignore that force. That's an assumption we make. The second assumption we make is G is same at all locations, right? Because with distance, G might change. If I go back to this discussion. For example, when you throw an object, right, if this distance is very, very large, right, if this is thrown through very large distance, g over here and g over here may change, may be different, and that may change things, but we assume that g is same for the entire journey, right? So this is the second assumption we make for projectile motion. Lastly, point number 7, I want to quickly write the definition of projectile motion, so you'll be very, very clear about it. I'll not write the entire definition, maybe the most important part of it. When an object is allowed to move in 2 dimensions, when an object is allowed to move in 2 dimensions under the action of gravity, alone, without being propelled by any other force. So an object is said to be performing projectile motion if it is allowed to move in 2 dimensions under the action of gravity alone, without being propelled by any other force. As we discussed all the examples over here, right, in all these examples, once the object left the hand of the thrower, the only force acting on it was gravity. Right? It was moving in 2 dimensions, it was under the influence of gravity, and there was no other propelling force. For example, a rocket would have a fuel which will propel it, but that would not be the example of projectile motion in that case. When the only force acting on is acceleration due to gravity, we call it projectile motion. Okay, with this introduction to projectile motion, in the next video we will take up a derivation for finding out various parameters for projectile motion, and we will also see how projectile motion is an example of parabolic motion. Right? Thank you.